Can I share my screen?
Yes, sir, you can share it, not an issue.
No, it is telling only meeting organizers and presenters can do it.
Okay, okay,
So you
okay.
need to enable me, I think.
Yes, sir, we'll do it. Just a minute, sir.
No problem, please.
Yes, sir, I'm doing it right now. Just a minute.
Sure. Oh, you've given the permission. Yes.
Yes, sir, now you will be able to share your screen.
Yeah, I'm doing that.
So, madam, let's start today's session.
Okay, so good afternoon, everyone. On behalf of Government Engineering College Modasa Computer IT Department and FDP coordinators and team, I warmly welcome you all to the AICT ATAL sponsored 6 days online FDP on advancement in data science and machine learning from concepts to applications. Now, today is the day 6 of the FDP, and we will begin our first session of today now. So, the topic for the session will be industrial applications of AI and ML. And for that, I would like to welcome today's esteemed expert, Mr. Alok Bhargav, sir, Senior Manager at GE Renewable Energy Noida. And he has a strong background in engineering, operation, and renewable technologies, and his work connects the field of sustainable energy and intelligence. So, with his industry experience and global professional credentials, he has been deeply involved in applying the cutting edge technologies to real world industrial challenges. So, today we will learn about how AI and machine learning are transforming the industries nowadays and deriving the innovation and creating smarter and more sustainable solutions, especially in the field of energy. So please join me in warmly welcoming Mr. Alok Bhargav, sir. And on behalf of GEC, I welcome you, sir. And now I would like to invite you to deliver the session, sir. So session is now yours, sir.
Thank you. Yeah. Source in AI and ML. I hope you can see the screen.
Yes, sir.
Yeah. So I've been working in manufacturing and construction industry for almost 20 years. And then since last 16 years, I'm working in the engineering and design group for electrical substations. By profession, I'm a civil engineer, but at the same time, I've done my post graduation in urban planning, and then I've also completed industrial engineering. I'm a certified engineer across the globe, like UK, USA, and Europe. And one of the thing which I did was associate value specialist from Save International USA. So we can say that I'm the least educated person here because I have never done a computer course. But yes, during the industrial processes, I found that we have been trying to maximize the profit by reducing the cost, increasing the value of the product. So these are some of the concepts on which today's session will be there. Like they say that there is of sale in everybody's life. They mean to say that there is a steel in everybody's life, which is produced by Steel Authority of India Limited. Similarly, I feel that artificial intelligence is basically a little bit of artificial intelligence in everybody's life today, whether it is using of Google Map or uh, basically you can say even the soft. As a civil engineer, I use Stat Pro to design the buildings. Earlier, we had to do with manually, and it used to take a lot of time. Nowadays, we can, with the help of Stat, we can go for as many number of designs we want, and then we can evaluate. So the contents will be introduction to AI/ML, and then industrial process, gaps in industrial process. At some places, still it is there. Efforts to close the gaps in industrialization, use of AI/ML to bridge the gaps in industrialization, case study of value engineering and use of artificial intelligence and machine learning in value engineering, and then to conclusion. So, needless to say, but still, I will give a just a small one slide. No, artificial intelligence to me, it is like a broad field of creating machines that can mimic human-like intelligence, while machine learning is a subset of AI that enables systems to learn from data and improve at tasks without explicit programming. AI includes various techniques beyond ML also, but we will restrict ourselves to ML because here it is AI and machine learning, such as robotics, rule-based expert systems. So here I just wanted to say that StatPro, which we are using, we are basically able to design today the buildings even for US, UK, and across the globe because it includes in it the rule-based expert system. All the codal provisions, all the specifications, etc., are there already inbuilt in the StatPro. And whatever codes you want to use, you can use that to design a building. Same building can be designed with Indian code or US code or UK code. And then whereas ML focuses on algorithms that identify patterns in data to make predictions or decisions. Here again, I would like to say that as a human being, we have to sometimes know wire our brain. They say that you have to rewire your brain. When you are going through some emotions, no, you have to rewire your brain. Similarly, you have to rewire, or you can say that you have to wire your AI machines. And like we behave based on our experiences, similarly, your artificial intelligence machines, they use basically data in place of experiences. Coming to industrial process, product development, supply chain and planning, manufacturing operations, quality assurance, logistics and distribution. I think most of you would have sometimes heard these terms or maybe involved also in this sort of things. So this is a very common thing. Coming to industrial process, the first thing is product development. No product can be successful in the market without a good amount of research going into it. So it involves like identifying the market needs, designing the product, and creating prototypes to test concepts and functionality. The second part of that is basically to choose the right raw material based on the product requirements. This is your market requirements, you can say. Cost, durability, and environmental impact is crucial here. This is your cost factor into it. So these are the two things, mainly market requirement and cost. These two you have to balance and you can succeed. The second is your supply chain and planning, ordering and acquiring necessary raw materials, components, and supplies from vendors, developing schedules and routing plans for the product process, and allocating resources like labor and machinery. We'll be coming to the other parts as well. Transforming of raw materials into individual parts through process like casting, forming, machining, or molding in the manufacturing operations. This is one of the, you can say, heart of the complete industrialization, combining individual components and subassemblies to create a finished product. Conducting, coming to the quality assurance rather, It is, that testing and inspection. I think in the softwares also a lot of testing and inspection goes into it. Conducting tests at various stages to ensure that the materials and the final product meet quality, safety, and industry standards. Implementing a detailed inspection to identify and correct any defects or deviations from the design. Earlier, the full product, once it is ready, at that time the inspection used to take place and whatever rejections were there. But nowadays it is as per ISO, International Standard Organization. We do inspection at every stage, right from your sourcing to the end dispatch, so that defect at any time in the process can be identified and it can be corrected. Packaging, logistics and distribution is basically packaging and shipping and distribution. Preparing the finished products for shipment, ensuring they are protected and meet customers' specification. Transporting the packaged products to wholesalers, retailers, or directly to the consumers. So this basically completes one thing and one part you can say. Are everybody comfortable?
Yes, sir. Yes, sir. Please go ahead.
Okay, sure. Now the first thing is your product development. How do we develop the product? First thing is to basically this all these things gap and these things I'm telling because first let us know what is going on and then we can bridge the gaps using AI/ML or where AI/ML can really help us. So translating requirements into a solution involves gathering and documenting needs from various stakeholders, especially the customers, as we say that the customer is got. So similarly, if he is not satisfied, then the product will never be successful. Further requires analyzing them to create detailed functional and non-functional specifications to design a solution that meets criteria. So our product should be good and not only good, it should be able to satisfy the purpose and the criteria which has been laid down. This is part one, which is basically marketing requirements. The second part is basically which every industrial person has to see is the cost. So additionally requires identifying the right raw materials based on the product requirements, cost, durability, and environmental impact. So we will be seeing two cases here, one for translating requirements into solution. The other one is to see how the raw material can be procured. This is basically a simple case of manufacturing a pen or basically product development for a pen. You can see here there are two things. One is worth, one is cost. The pen, what is the worth of it and what is the cost of it. And this ratio basically plays a very important role. Here you will see in the left hand corner there is a relation, a strong relation basically between 1 to 5. So low relation is 1, medium relation 3, strong relation 5. These are basically customer needs. So the customer needs that as per that the pen should write smooth, should not leak from the ballpoint, should have proper grip, cap should be tight, should write darker, should look good, should not be broad, should be lightweight, and ink should not finish. And we can have our own criteria depending upon different sect of people, like a person who is basically say a common man, he will have his own importance and he can give the importance rating based on his experience or his requirement. And similarly, if there is somebody who is extremely rich, his priorities or you can say importance rating will be different. He will surely like to have a pen on which his name is printed in golden color. He may like to have a cap clip which is very beautiful. And though his intention will also be same that it should write smooth. So if you see the components of the pen, as you know, body, front ferrule, back ferrule, rubber tube, refill, refill body, nib or ball, ink, cap cover, cap clip, and printing on the pen. So every body part has got its own no, functionality to hold writing, to retain refill, to support refill, to grip, to store ink, ease of friction on the paper, to mark on pen, to protect, to hold, to look. Now, if you see the first function, first customer need should write a smooth. This will have very less, you can say, coordination or basically relation with your body of the pen or front ferrule because to retain the refill. So if pressure is not there, the writing will not be smooth. So it may have little bit of relation with front ferrule, back ferrule, but the maximum relation of should write smooth will be with nib or the ball of the pen. And similarly for others also, other customer needs, it will have different relation with the different components. So based on that, you have importance rating, which is given by the customer. You have got the, you can say, relation with the component relation. So this has got different rating here, a strong relation, medium relation, low relation. So that is what is given. And we are not finding out the worth in absolute rupees or dollars. We are finding it in terms of percentage. Similarly, cost also in terms of percentage. And then worth by cost, which is your value ratio. This, say for example, for body, it comes 0.535, and for front ferrule, it is 1.113. So what happens here that if the value ratio is zero point 0.5, it means that cost is more, worth is less. It means that we have to re-engineer that particular item. Similarly, for front ferrule, suppose it is 1.113, it means that your worth is more than the cost and you are giving basically additional value to the customer. So this was the concept of product development. Now here we will see AI and machine learning, how it will can help us basically to translate the business and system requirements into actionable solutions by learning patterns in data to perform tasks like translation, analysis, prediction, and automation. We have seen here that lot of data here, if you see, basically whatever we have given the importance factor or the basically component rate. This requires just a simple exercise. So that's why we have made our own criteria and we have put it. But to put 9.23, this requires basically lot of research or lot of survey with the customers that what is their priority, and similarly also how it should look like. For all those things, you require a lot of data, which can be basically a very tedious job for a human being to do. And here basically AI and ML can help us to basically translate the requirements, analyze and predict, and do the automation. In the context of translation, AI model analyze vast bilingual datasets to understand context, syntax, and grammar, enabling them to generate more fluent and accurate translations than our traditional methods. For instance, a system might use NLP and neural networks to convert user requirements into specific translation workflows or combine AI with human oversight to verify and refine machine generated translation for high stake applications. I was just going through the literature and somewhere I saw that Pfizer uses NLP techniques to scan extensive research letter and clinical trial data during drug discovery and development, which helps researchers identify relevant studies, potential drug targets, and hidden insights buried in the scientific publications, significantly accelerating the R&D process. Now coming to the material selection, I think everybody would have surely seen concrete, and you must be hearing that the concrete is not good and things like that. So to be very brief, the main aim of the concrete is basically once you are putting the big air aggregates, the voids between that should be filled with smaller, and the voids between the smaller with still particles, and then sand and then cement. So to get a proper aggregate mix of coarse aggregate or gravel and sand, it is very difficult because it has basically uh, downsizing. You can say sieve analysis is done so that you know what percentage is passing through which one. And if that is not proper, the gaps will be there, and those gaps will ultimately lead to lesser strength of the concrete. So a concrete mixing plant had to supply M15 grade concrete in large quantities to a dam project. The mix proportions were estimated raised to 1 raised to 1.9 raised to 4.54 by mass. This concrete required basically sand and gravel mixture of 30% sand and 70% gravel by mass. This was basically by mixed design. The natural deposit at 5 pits sites were found to have different compositions, and their cost, including transportation to the sites, also varied, as shown in the table which will be coming in the next slide. However, the constituents satisfy the specifications, and we were supposed to determine the quantities of deposit to be obtained from each source in order to minimize the cost per cubic meter of concrete. So as usual, there are 2 points. One is the you can say the customer requirement, that it should be good concrete uh, as per specification, as per code. And second thing was the cost, which anyone would like to have it optimized and minimized. So you can see here, there are 5 pits, very simple exercise. 1, 2, 3, 4, 5. And the sand percentage in this basically varies from 20 to 55%. And the gravel basically from 45 to 80%. And the relative cost, I have not put here the absolute cost, relative cost per cubic meter of mixture. So it is ranging from 1 to 3. To determine the quantities of deposits to be obtained from each source in order to minimize the cost per cubic meter of concrete while satisfying the constants of sand being 30 and gravel being 70, we went for linear programming equations. And these equations were solved using simplex method by applying AIML. The model, once trained on the large data set, may be able to provide real life solution, as the situation in real world is very dynamic and raw material properties and rates are changing frequently. Once you are quarrying, no, you are excavating the stone to go into crusher, and it basically gives you aggregate and sand, or you can say basically crusher dust. What happens sometimes that while sieving, if one of the opening is more, it will give you bigger size of aggregate. So this here it means that the raw material properties and rate changes frequently because of this reason, or the rates changes due to so many reasons which are there. And with this chat GPT output, I had used chat GPT. So pit 4 was basically 28% to be used, and pit 5 was basically around 72%. This combination exactly meets the 30% sand requirement and gives the minimum cost. So this is at around 2.07. Pit 4 basically, why this particular mix? As you can see there in the table, pit 4 is the cheapest, relative cost 1, but sand rich of 55%. Pit 5 is basically next cheapest partner with 2.5, and sand and this thing is sand is around 20%. So blending this particular ratio, and we can get for whatever cubic meter of concrete is it is required, we can go with this. Now, what I was talking like ability to quickly adapt to change in parameters. Suppose the cost of pit 5 has increased by 20% now. What should be the optimal mix? So we can go again back to AIML or AI basic GPT, and it will give you the new ratio, and it will also tell us that what will be the relative cost now in relative units, what will be the minimum cost now. So not a big one, but yes, the chat GPT also gave us this one particular your graph. So you can see here that the minimum ratio, basically you can see here it is around 28%, and the relative cost was basically around 2.0 earlier and now 2.4. Coming to gaps in the current process of supply chain and planning, gaps in supply chain management stem from a variety of internal and external factors, including a lack of visibility and communication, increasing costs like fuel and freight, demand forecasting errors, technology integration issues, a shortage of skilled labor, disruptions from the geopolitical events or extreme weather, material scarcity, and inefficient process. So if you see the supply chain and planning, again our last particular exercise, what we were seeing for aggregate and sand, this is basically a case of supply chain and planning or sourcing, basically the raw material sourcing. So these gaps leads to operational inefficiencies, higher cost, and diminished customer satisfaction. So in industry, basically customer satisfaction and cost, these are the two main, you can say, factors which are basically monitored by the higher management. Even I understand that in colleges also nowadays this concept would be there, that the customer satisfaction or the students and their parents, they may be satisfied, and the cost should be low. Now, this AI and ML are transforming the supply chain management by optimizing operations, improving forecast. Forecast is basically again based on the data and surveys. So this basically again it calls for a huge data set which has to be again processed through artificial intelligence and increasing efficiency through data analysis and automation. Key applications include more accurate demand forecasting, smarter inventory management. I think in regarding inventory, everybody knows about just-in-time inventory, so that neither you have huge inventory which is not required, nor you are short of inventory. Optimized logistic and route planning, enhanced warehouse efficiency, improved risk management, and better supplier relationship. All these things we will be coming little bit we will be discussing in the coming slides. By integrating AI, businesses can gain deeper insights, reduce costs, minimize disruptions, and make more data-driven decisions. So to me, basically data. Other day, I was hearing to one of my senior management person, because we are not using any chat GPT or any artificial intelligence tool in our company. So in one of the forum, somebody asked him that when the world is using all sorts of artificial intelligence tools which are available in the market, why we are not using it officially? This is all we have done on my personal level. So why we are not using that? So his reply was that data is gold, and our own company's data, if we are basically using or basically feeding into any of the artificial intelligence tool, it will go to many people. And then what will happen to our data and the basically your own patents and things like that will go for a six. So we are basically our company is making their own artificial intelligence tool. It is in the process of development. So Once it is ready, we have to use that only. So why I called it here, why I'm basically giving this example, because like owning the data and to maintain its privacy or to secure it and safely, that will give you basically deeper insight, and always a competitors means you can have an edge over the competitors. There are coming to manufacturing operations. This is really interesting. I feel that you will enjoy this. As everybody knows, right from the my side days, we used to call LMP. LMP means your labor, material, plant and machinery, and spares basically of the plant and machinery. Because if spares are not available, your plant and machinery may go down. So in labor, terms of labor, basically time delays, idling, identification of necessary and unnecessary waste activities in processes. Materials, basically availability of raw materials, supporting materials required for timely completion of processes. And then coming to plant and machinery, minimizing breakdowns and downtime of plant and machinery. Spares, basically timely availability of spare parts for plant and machinery to avoid delays. I'll just give you a small example, which we used to face in site. I was working with L&T at that time, and all the scaffoldings and shuttering materials, we used to use DOCA system. You might have seen blue color pipes, no, with yellow color wooden beams. Those pipes, blue colored pipes, are basically connected with small hardwares. And to connect even the wooden beams with the scaffolding, we used to require this small components. What used to happen was that big material will come first, all the pipes in tonnage, and the smaller items which are required to basically connect them, either it was short or it was basically never sent. So it was not the mistake of the labor. He used to bring the material, but he was not able to erect. So time delay, idling, making some jugaad, making some temporary arrangements to erect those things. So this is what basically we are trying to identify here. Materials, basically, again, as I told you, gave you the example of aggregate, sand, cement. These are again very crucial. And plant and machinery, the downtime, basically, I remember when we were inside we used to have trucks. They used to come and then they used to stand idle because due to either some breakdown or diesel is not there or something like that. So this is the concept basically. So these are where the gaps in the current processes, even today also, I feel that these gaps are there in the manufacturing operations. Now coming to use of AI and ML in manufacturing operations, I have given these 5 signs with a purpose. So I would like to know from you why I would have given these 5 signals. Signs rather, sorry. Can anybody guess? Okay, so these are basically the senses which a human has. And in artificial intelligence also, we want the same thing to be duplicated with our artificial intelligence tools, which many a times are using sensors, IoT sensors, you call it, no? So you have computer vision, and then for temperature recording, that is your touch, you have got this IoT sensor again. Noise sensors are there. I feel that for smell, obviously the sensor may not be there. What I want to say here is the integrated steel plants or cement plants, they are basically very huge, 10 kilometer by 10 kilometer area. And everywhere you don't have the people, everywhere you don't have the smoke detectors, everywhere you don't have the automated water sprayers. Some remote places, the cable may be kept as a bundle and it may catch fire. So there should be some sensors which can basically give you the signals regarding the smell of the fire or the smoke. If you cannot put a very expensive smoke detector and things like that, it may not be able to do also. Similarly, before bursting, any pressure will give you a sound. So if your normal day sound and if any abnormality happens, there will be a variation in the sound. So those type of sensors can help us in big plants, whether it is oil and gas or fertilizer or a steel plant. It can help us by giving the signals that something abnormality has happened in the site and you should take care. Computer vision, that is basically developed in itself. It basically gives you the signals by deciphering the images. Similarly, for heat also you have the sensors. Taste, I though the figure has been the sketch is this thing, image is there, but that may not matter much unless you have some abnormality in the water or something like that. Sorry, I think some mistake. Okay. So this is regarding manufacturing operations only. Uh, I'm sorry for putting this thing wrong. AI and ML are revolutionizing the time motion studies by automating data collection and analysis from videos, identifying waste in the real time, detecting anomalies, and optimizing processes for increased efficiency and productivity. Already, this is being done by humans also through lean exercise, Kaizen we call it. So, wherein the necessary and unnecessary waste in terms of your activities are basically removed to make the process fast or to optimize the processes. But with the help of AI and ML, we can really do it faster without basically, you can say, without avoiding or without basically the things which cannot be detected by human can be done by AI and ML. Materials and machinery spare parts. AI and machine learning can significantly enhance just-in-time inventory by providing highly accurate demand forecasting, real-time inventory visibility, dynamic safety stock calculation, so that if the particular stock is going below certain level, it will give you a signal and you can again do it, or the artificial intelligence tool itself can basically order, and proactive risk mitigation. Predictive maintenance. Basically, earlier when the machine used to go for a total breakdown, then we used to call the mechanic. Then there was a capital repairs or capital maintenance period, the second stage. People used to shut down the plant and then they used to go for maintenance of that. Then the third was basically total preventive maintenance, trying to prevent any breakdown. And now it has come to a level where we are going for predictive maintenance, which can help to reduce the machinery downtime. For machinery having rotating parts, the common symptoms which give insight to future breakdown are vibrations and temperature. So the IoT sensors attached to machines can detect vibration, increase in temperature, and provide signals to instruments model to receive the signals and take appropriate actions to prevent the breakdown of the machinery. Now coming to quality assurance Quality assurance is a proactive, process-oriented approach that focuses on preventing defects by ensuring the entire development process, and it is designed and executed correctly to meet the quality standards. There are two things. One is quality assurance, which will basically see that you give a good product to your customer. The other one is your quality control. Basically, you take some measures to ensure the quality in check, and then you do the inspection and find that yes, it is as per your required parameters. So here the key gaps which we could find is customer expectation gaps. Basically, the customer is told, I will give you a very good flat, sir. Don't worry, it will have a good strength and nothing will happen to your water leakages and things like that. But when the customer goes and experiences, he finds that the water is leaking. During the rainy season, there are seepages and all those things. So this is what I call customer expectation gaps. Management perception gaps. Basically, the management itself is not able to perceive the customer's requirement properly. So that is management perception gaps. Process gaps means during the process of making, if any gap is there, the final product will not be a good one. Communication gaps, when you are not able to communicate properly to down the line, if there is a poor communication or you have missed to communicate something, that may go wrong. Skill gaps means you are having little bit of knowledge, but you don't have the required experience to do that job. So that is what I call skill gaps. And nowadays, uh, in our field also, in construction industry also, we are not finding the right people who have sufficient knowledge to do a particular job. So this is knowledge gap. Now coming to your use of AI and ML in quality assurance, AI and machine learning in quality assurance automate tedious tasks, uh, which can basically, uh, if a human is doing that task again and again, time and again, and if it is a tedious one, he basically do some mistakes. Coming to enhanced test coverage, basically the test covers all the cases and enable predictive analysis to identify potential defects. This is one of the important things so that if you can basically identify potential defects and high risk areas before they occur, you can basically either change your test script uh, to take care of those particular potential defects and you can get a proper one. Automated test creations, self-healing automation, wherein basically in the automated test creation, basically the user stories are used to change the test script so that you get a good product. Self-healing automation means again by using the user interface uh, what do you call it, inputs, the test script can be taken care of. Predictive analysis, as we were talking about, that if you know what type of faults are there based on your previous data set, you can take preventive action either during manufacturing or during the test. Enhanced test coverage, basically complex scenarios can be solved or can be taken care of by using algorithm, and also means your edge cases. In this, I would just like to say something. My son basically is a computer engineer and he is into automation, and he generally tells that when he has completed the his coding and everything and he tests, when he is testing it is coming correctly, all the things are proper, but when it goes to the customer, it may have some or other error. So this is where basically, because being a human you may leave some things, but AI will not leave it. So they will basically AI will cover almost everything. so that there won't be any mistake in that. And then improved accuracy and reliability. Coming to this logistics and distribution, gaps in logistics and distributions are the discrepancies between the actual and desired outcomes, such as late deliveries, inaccurate inventory, poor communication, with negatively impact businesses through higher cost and lower customer satisfaction. So the two main aspects what I see here is higher cost and lower customer satisfaction. When I was going through this, I was just remembering a case. Suppose you have booked a taxi to say go out of your town. So what we generally face is number one, late deliveries. You are supposed to start at 7 o'clock. It comes at 9 o'clock. So that is delivery gap. Inaccurate inventory. The phone will come that sir, the vehicle is not available today. It has to be done tomorrow or something like that. So that is your inventory gap. Poor communication and service gaps. Sometimes what happens that the person may not communicate to you his inabilities, and he will send somebody who may not be that good, you can say person who drives the car or vehicle. So that is your service gaps, or the vehicle may not be clean, it may be smelling. So those are service gaps. Information gaps, as I told you, sometimes they do not give the information. And the last one is your skill gaps. So skill gaps here is the person who is supposed to do a good driving. He may not be very good at that. He may not have the required experience. So these are your skill gaps. For logistics and distribution, the first one is warehouse management. So by coding using barcodes and having this artificial intelligence tools which can basically see the barcode and they can basically tell you about the inventory. So just in time inventory basically, which in which neither you have the over products nor the shortage of products. So that is warehouse management. Coming to demand prediction, again based on your data set, the artificial intelligence can give you a proper demand. Logistic route optimization, I was telling you about the Google map. So it can give you a optimized route, as well as it can basically predict your pre-covers. Then coming to foreign language data cleansing and building data robustness. As I was telling you that we are having, since I'm into G, wherein we are basically supporting almost all the countries across the globes. And many a times it happens that the specifications or the vendor data, things like that, the different data, it comes in foreign language. So you need to basically uh, translate into uh, tacit language so that you can understand that, and you can keep it, you can make a good data. And here basically you are we are using this mobile apps for translation and things like that. So that is again one of the artificial intelligence by basically going into the layers of that language, or what do you call it, NLP, so natural language processing. So with the help of that, you can basically translate and make your own data bank. And then comes your drones, which are used in the delivery, and autonomous vehicles. I think somewhere I heard that in Dubai they have started vehicles without drivers with AI and other things. But I think that was not very much popular, and you understand that world is not yet ready for that. So AI basically, what I find is optimizes delivery routes by analyzing traffic patterns, selecting most efficient paths, This use of AI not only reduces fuel consumption and delivery times, but also helps minimizing logistic operations carbon footprint. So this is one of the main thing which has come nowadays, sustainability and carbon footprint. So while making any product, you have to have a conscious mind about your carbon footprint and sustainability as well in industry. Now we will come to this value engineering and use of our particular topic in value engineering. So we have completed almost application. Now we are going to start something different. Everybody comfortable, or have I gone little fast, or how I should go? Hello?
Yes, sir. I am
Hello?
allowing participants.
Is it okay?
Yes, sir, absolutely okay. Please go ahead.
Okay. Okay. Uh, Again, this why this particular value engineering I have taken up here is I am myself a certified value associate value specialist from Society of Value Engineers USA, and this is one particular subject which is not only which is very valuable for industry, but apart from that in our life also it is very much useful. And nowadays, with the help of AI ML in value engineering, a lot of things are happening. And to give a brief about it, it started uh, in my own company. One of our engineers, way back during the First World War and Second World War, they were supplying the engineering goods to US because GE is from US. And they faced the problem while manufacturing. They faced that there was a shortage of raw material. And then it was decided by the engineers, group of engineers, to do value engineering so that they can have a substitute material, substitute process, or have a something different from what they generally used to do. And that's how value engineering came into the concept. We will discuss a short case study also after this particular slide. So this will enhance value engineering by analyzing large data sets to identify cost saving opportunities, generating alternative designs, and improving decision making with predictive analytics. These technologies automate repetitive tasks, streamline workflows, boost productivity, and increase accuracy in tasks like quality control, resource allocation, minimizing cost, enhancing product performance. So this can be done by having data-driven insights, generative designs, predictive analytics, again same thing, automated process, optimized resource allocation, and streamlined workflows. You know that the whole concept of our artificial intelligence and machine learning is based on the large set of data. The more the data you can feed into that, it will give you better uh, predictive analytics, sorry, uh, to automate the processes based on the data. It will have its own algorithm wherein this data can be fed, and it can have the patterns and the trends which can be helpful for future decisions. Similarly, apart from these 6 points, I was seeing one more point wherein the AIML can basically, with the help of the data set, it can tell you Feature optimization. Feature here means FEATURE, the features which are there in the product. So optimization of those features, whether that particular feature is being used by whether it is popular amongst the consumers or it is not being used. In our own mobiles, we have got so many features, but we are not using all the features. So which are the features which we can remove? Which are the features which can be retained? So this is the concept here. Sorry. Okay. So value engineering, a vital tool for sustainable growth. Here, I will take the liberty to give you a case study which is related to construction industry. And here, value engineering, best practicable environmental options (BPEO) to gain the time. We have the sustainable growth. Resource optimization. This will lead to low carbon emission or carbon dioxide. Reduction part count or weight in reduction. So change in process or product. Basically change in technology, change in process, and eco-friendly technology like solar power, wind energy, etc. to basically improve the productivity. This called for external team. So we were doing a project for Tata's, and our client was Tata Steel Limited, and the consultant were TCE, Tata Consulting Engineers, and we were there as IPC contractor. So value engineering at its best in the design build organization, like our previous company, and basically it starts with engineering and design. Especially any good value engineering will start at the design phase itself, so that you can optimize everything, and then to procurement, and then to ultimately construction. And we had three sections: civil, electrical, and HVAC, heat ventilation and air conditioning. So this was the setup. The first phase of value engineering generally is team formation. We had a team of people, and the project was to basically install 400 kV switchyard on a fly ash oblique slag mound. It was a man-made hillock, almost 16-meter high, on which we were supposed to put a 400 kV switchyard. So phases of value engineering job plan: selection phase, information phase, function phase, creative phase, evaluation, development, presentation, implementation, and audit. So in this particular exercise, there was change of material, change of process, change of design. This was somewhat the layout. We had there was a level difference of, I think, total 8 meters, 173 to 180.5. So 132 kV switchyard was at lower level. This was at level. This was the slope protection, and this slope protection was basically replaced by stone pitching. The cover was of stone pitching, and here it was grass. I think when you will see the photographs, you will understand better. So function phase, basically slope protection. The value engineering basically again depends on two things only. One, you have to describe your item into verb and noun. It was here, function verb was prevent, erosion, slope protection, basic function type. and then you have the present cost. You need to find the alternative way. Now, if I ask a human being or a person, he may be able to give one or two alternative ways that change the material to grass turf and things like that. But if I put it into a AI tool, it will give me many a particular this thing, no, alternative methods along with their cost and value gap and value index. And the second part was to put the switchyard foundation in a fly ash hill, and we were not very sure how to do it. So therefore here we were again into function verb transfer, function noun load. The function type was basic. This is the heart of value engineering. You have to ask how and why. And this can be done for any exercise, whether you are making a software or you are doing coding, how to basically optimize everything, and what are the alternative ways. Say, for example, to support load, how you can support load. So by transferring the load, how you will transfer the load? By again, by providing approach, withstand the load, withstand the moment, prevent rotation. How you will transfer the load? Again, by distributing the load. You would have seen that any foundation is not on a pinpoint, it is rather on a broader base. So distribute the load. How it will distribute the load? By withstanding the load, withstanding the moment, preventing the overturn. Receive the load. How it will distribute the load? By receiving the load. Um, by again withstanding load and prevent buckling. And how you will receive the load is by applying the load. So this is a simple case of basically, going to design a foundation. I hope this is not something very tough to understand. I hope that this is not very tough to understand. Am I right?
Yes, sir. Yes, sir.
Yes. So simple things.
Yes.
And while doing this thing, we have to see that we meet the specifications, we achieve the factor of safety as per specification. And this basically can be applied to any activity in the shop floor of any industry. If you are very unsure, you are not knowing how to do a thing, you have to simply break down into different components. It can be applied to even to a manufacturing unit as well. The second was basically to protect the slope. How you will protect the slope? By preventing erosion. How you will prevent the erosion? By providing cover. How you will provide the cover? By receiving the protection, and that is by applying the protection. And meanwhile, these factors should also be taken care, like prevention of movement, provide stability, withstand the force. To provide cover, basically it should support the soil, shield the soil, and prevent the overturn. What we are seeing nowadays, so many landslides. And similarly for receive protection. And meanwhile, again, we have to meet all the specifications and achieve factor of safety as per specification. This was basically, as I was showing you, that this is 132 kV, 8 meters below. This is 400 kV. This was 8 meters above. And we had a slope protection here. The cover was using stone pitching. We could have gone for some alternate material like grass or other things also, but in a switchyard, we see that vegetation does not occur because ultimately it will dry up during the summer and it may catch fire. So that is why we have gone for this stone pitching here. The slope was 1:1.5 green cover, and for basically boulder soiling, slope was 1:1. There was a space constant between the two switchyards. So that is why we have gone for change in dimension of 132 kV switchyard and gone for this 1:1, which is boulder soling. And due to space constraint, again the slope was changed to 1:1. So change the material to stone pitching, reduction in cost as compared to shotcrete, what we earlier thought, no environmental benefits, disadvantages. Changing the material to grass turf, reduction in cost as compared to shotcrete and stone pitching, and environment benefits, which was basically a bigger, you can say, bigger factor nowadays. But disadvantage was maintenance required till maturity, till the grass is basically sufficient enough to take its own care. Maintenance was required. And the ways to overcome was to give the maintenance contract to some subcontractor. Then basically it is a technical thing for foundation system, like the geological controls on the formation was not there because it was a man-made fly ash hill. Soil behavior was not well understood and things like that. Basically the technical justifications to go for pile foundation. So here again, the idea was to cement grouting of the complete mound, because if you have a small hillock of fly ash, you have to grout it with cement so that it can withstand its own under its own weight. So solid base for foundation, stabilizing of mound in single operation, no environmental benefits, damage to environment by heat and generation and carbon, heat generation and carbon. The second was comprehensive soil investigation and selection of type of foundation based on technical investigations judiciously for open type of foundations instead of piles. So where the soil allowed us, we went for open foundation. Other places we went for piles. So optimum use of reinforced cement concrete, stabilization of soil using eco-friendly approach, less drilling in soil. Coming to evaluation phase, tangible benefits, monetary gain because you are reducing the cost, conservation of natural resources, improvement in productivity. Environmental benefits in this particular case was generation of 1.75 tons of oxygen because we had gone for green cover outside. Absorption of almost 9 tons of carbon dioxide, carbon per year, brings down the ambient temperature. Any green cover will bring down the ambient temperature. Avoidance of almost 1200 tons of carbon dioxide by use of cement or by making it by not putting the green cover, carbon dioxide would have generated. Avoidance of 410 kilojoules of heat of hydration for cement and concrete. Avoidance of suspended particulate matter in air. Coming to evaluation phase, again, these were the criteria. Here, basically, I would like to say that this sort of exercise, which is done by human, here AI can help us a lot in value engineering. You can feed this data, you can feed this, again, basically your tacit knowledge into your AI. You can model it for that and it will give you the results. Like here, ease of design, code is A, ease of erection, time of implement, savings, effects on environment, and then basically putting one against another. Suppose if ease of design and ease of erection, if you compare, so you have the points here. So like this for all the five identified criterias, you can have this rating on 1 to 10. Here, basically, our artificial intelligence, machine learning, by giving it them a data set, a vast data set, you can basically bring the model to such a situation that it can give you better results. And we can do something else. Idea compression. So here basically same thing is elaborated like a slope protection by shotcrete, protection by grass turf, slope protection by stone pitching, for foundation type or foundations of pile type, comprehensive soil investigation and judicious selection of type of foundation, grouting of the mound with cement. So here ease of design, ease of erection, like that you can have the different scale on which you weigh these ideas, and then you come out with the idea that slope protection by grass turf is the best one. But here in our case, we could use it only for the periphery between the two switchyards, though it was the solution was number one as per the weightage and the criterias, but we had to go for number three because that was basically more suitable in the electrical switchyard. Then it is development phase, how you basically build this slope. You can see here that the complete slope is filled with fly ash and steel plant slag, and we have dressed it in such a manner the slope was maintained so that the particles will not come down by itself, what we call it as angle of internal friction. So it was basically based on the angle of internal friction, the slopes were cut so that it will not come down automatically. And then these jute layers were put, this is I'm talking somewhere around 13, 14 years back. Nowadays, the technologies have developed to a great extent and a lot of work is being done in the northern area in Uttarakhand and your Himalayas to basically stabilize these landslides. So here your jute bags were there, over this cow dung and other things were spread, and then the green cover was put here. You can see here when we took over the site from them, this is 400 kV switchyard, and this was the position, no situation rather, I should say, that it was totally filled of flies. It was very difficult to stand there without a mask. And then during the development phase, basically, what were the responsibilities? Who will take care of what? All those things are. These are basically steps which you have to cover if you are doing a value engineering exercise. And then presentation phase. This is that was, you can say, this was when we took it from the client, and this is what we provided them. It is same area. This is what we have provided to our clients. So value engineering or installation of 400 kV switchyard and total implementation cost, expected cost advantage after amortizing to tooling cost, and then expected cost advantage after subtracting full implementation cost and expected implementation dates, etc. in the presentation phase. You can see the implementation phase. As I told you, this is what we received and this is what we gave them before and after. Again, implementation phase, the cost and other things here. And in the audit phase, basically, whenever you are doing a value engineering exercise in any company, they will ask you to get it get the audit done by the financial people, that how much you were able to save. Unless they sign, your value engineering exercise is not completed. So this was regarding the audit and all, because it was presented somewhere else also. So I could not basically give them the figures of my company. So concluding, basically, if you see right from 1784, mechanization with water power, steam power, industry phase one. Then came your mass production assembly, mass production assembly line, electricity phase two. And then industry three by using computer, electronics, and automation. Industry four, cyber physical systems, IoTs, and networks. And now what we are going into is industry five. I think it has already begun. Mass customization and cyber physical human intelligence, cognitive systems. So we are moving towards more and more of artificial humans to help us. A lot of movies are also there for artificial humans which will come and they will make our life easy. So this is it. Thank you. And we have not inherited the world from our forefathers. We have borrowed it from our children. So we have to give them back in a good shape, sustainable development, and less carbon footprint. Thank you.
Thank you, sir. Now, if any participants wants to ask any questions, please raise your hand, or they can write it in a chat box. Not an issue. Any question from the participants?
So for a question answer, I have allowed participant to unmute themselves. So if they want, they can wish on their own for now. So you can ask questions now.
Okay, no question. Fine, sir. So thank you so much, sir, for sparing valuable time with us and very informative session. Uh, Actually, till today we have learned about the technical aspects of the AI and ML, but today we can learn about, I mean, we learned about the interdisciplinary requirement of the AI and ML. So definitely the AI ML engineers can provide the knowledge for finding the solutions in others domains also. So thank you so much, sir. Hope all the participants enjoyed it a lot, and we can move forward to the second session. Thank you, sir.
Thank you all. Thank you for sparing your time. Thank you.
Hello,
And
sir.
listening me. Yeah. Yes, madam. Tell me,
Sir, I have a question on behalf of our placement team. That
please.
what are the qualities, because of your industrial experience, what are the qualities that you guys are looking in today's means upcoming engineers? So apart from coding and algorithms, what are the properties that you are looking in them?
You see, we have our own, no, like right now I am into Global Engineering Center, who is basically supporting almost all the regions in the world. And in our own Global Engineering Center, when it comes to computer, uh, we have a small team of cyber security. So that is the one of the thing which is coming up very fast. And you might be aware that today's world is very, it has become very small. Like all the grids are connected to each other. We are doing some project where in Netherlands and Germany are getting connected through HVDC. Singapore is getting connected to Malaysia through grid, through cables. And these are all basically nowadays it has become very, very, you can say SCADA and your power distribution and the parameters of power which are basically controlled, they are all dependent on computers only. So cyber security is one of the topic which is very important to us because a threat is always there to all the uh, power distribution agencies. And to safeguard the main heart of electrical power network like SCADA and other things, we have our own security people who are basically into how to manage the cyber security of the complete network. So this is one place where we are doing the job. And then basically when you come to manufacturing, we do have, our company has basically, all electrical equipments are being manufactured by us, and including in alternating current or high voltage direct current. You must have heard of HVDC projects nowadays. So soothing reactors and transformers and your circuit breakers, all those equipments are also being manufactured by us. So whatever artificial intelligence or use of machine learning to in the manufacturing sector, which I was telling you, that is being implemented there. And
Yes, sir.
even construction industry also, like CNC machines are there, and there are basically a shared skill center for even small thing like cutting of rebars. You have got the machines to cut it to proper size. You have to just feed in into your bar bending schedule, and it will give you the cut pieces along with bending and everything.
Yes, sir. Okay, sir. So it's not just limited to computer IT students, but all the branch of engineering.
To an extent, yes.
Yes, sir.
So I am a civil engineer, but working for an electrical company. So around me,
Yes,
all
sir.
are electrical engineers, and they are talking about this only.
Okay, sir. Thank you, sir.
Thank you. Thank you all. Bye.
Bye, sir.
Should
Bye,
I?
sir. Have a good day,
Thank
sir.
you. Good day, madam.
Okay. Uh, Now, all the participants, please stay here. Our second session will start soon. Our second session's expert is going to join us soon. Uh, yes, yes. He's joining us within the 2 minutes. So let us wait here for 2 minutes.
Hello. Hello.
Yes, madam, I think
Yes, sir.
expert has joined our meeting. So
Yes,
let
sir.
us start today's
Just a
session.
minute.
Thank you.
Uh, mm, Let me make you, sir, a part presenter. Just a minute. Okay. So now we will begin a second session for today. So the topic for the session will be case study in data science. I am audible. Case study in data science, solving the real world problems. And it is my privilege to welcome our expert, Mr. Parth Parikh sir, who is associated with the Google Cloud and brings the rich expertise in data-driven technologies and practical applications of it. So, with the years of experience in industry, he has been instrumental in leveraging AI and data science to address the complex real-world challenges. And so we will learn that how data science will be applied into domain such as industrial and strategies that can be bridge the gap between the theory and practical. So on behalf of Government Engineering College Modasa, I warmly welcome you, sir, and we look forward to your valuable session. So I will hand over to you now, sir. The session is yours now.
Thank you for the opportunity to conduct this session. So before going, I'll briefly introduce myself. My role over in Google Cloud is mainly related to conversational AI engineer, where I'm working with CCI products like summarization, smart reply, and all. So mainly my tasks are involved around NLP. But apart from that, there are some tools and technology that an AI engineer needs to utilize while doing the work in data science. Okay, so previously I had worked for a predictive maintenance industry where I developed certain algorithms. So in the case studies, I'm going to discuss the cases that I have resolved and that I utilized, the framework that I utilized, and all that. Okay, let me share my screen. Okay, let me share this. Just, okay, okay, is my screen visible?
Yes, sir.
Okay, okay. So though I didn't put much content on my slide, but I'm going to discuss mainly about data to decision, the life cycle of data science that we follow, and then how. So I have kept one more slide specifically for mapping industry and academics. So like, what are the industry perspective when we utilize data science technologies to resolve certain problem, and what an academician can do as a fact. Like, I understand this is for faculty development, so definitely how you can integrate your work with the industry's work to define some problem and to resolve some problem. So for that, I have just kept one slide about uh, digital transformations, and then we are going to discuss a couple of case studies. Okay, so this is there are two kinds of framework that I'm going to discuss. One, data to decision, like what we need to do, and second will be technical life cycle of the data science solution. Okay, so I know you all must be knowing about this. Like, this is the data science pipeline that you would have used. So first, we are going to think about the raw material. Now, whenever we start a problem, we start resolving a problem, we need to understand like what is the need of the data. Now, what happens generally right now? So if you go to the industry, if someone says you that I want to resolve a problem where I can resolve issues of customers uh, in a faster application mode, and then what should be done? Normally, when you start without any experience, what people does, they directly utilize or they directly collect all the data that is there in the application, and due to which you add noise in the data. Okay, so first you need to understand the data that you have, the raw material. You do not need to collect each and every data. Okay, we are going to see the same slide but with resolution of a problem. So the whole journey starts with the raw material, the data that we collect. Next, we need to understand like why are we collecting this data? What are we going to get? What are the insights of the data? Like for an example, if I say the subscriptions of Netflix is going down, or the subscription of Amazon Prime is going down, then that means they need to understand like why it is going down. That can be understood from the data only. So next step, we need to get the insight from the data, like why it is going down. These insights can be achieved through some graphical formats. So that can be descriptive, there can be some statistical parameters that we understand, and sometimes it may be due to non-technical things also. So generally, when we collect the data, when we utilize the data, create the model, and a model is there. So let's assume Netflix the same way. It is performing very well. The subscribers are going like increased day by day. They are getting success. After certain period of time, their subscriptions are going down. Now they understand from the data. They understand that model is performing the same it was. Data is also the same it was. Then what can be the reason? Sometimes not only technical, but there can be a concept drift into the data. Like now, the whole concept, so initially it was kind of mixture of all genres of movie, but now people are people are preferring a specific kind of movies only on Netflix. That can be the reason. Now this is not a technical reason, but this is again a concept drift. This kind of insights we need to get from the raw data that we collect. Now once we have this insight, what should be done next? What can be done? So this insights needs to be used for some decision on basis of. So now they understand the trend, they understand the drift in the concept, and they decide that okay, now as these kind of genres, so let's assume that specifically for Indian or Bollywoods, so now people are preferring a kind of mass movies, so they need to occupy those movies in recent changes, and that can increase their subscription from the specific region like India. Okay, same way customer churns. So like customers are dropping for Geo. They understood that okay, it was, so this is a real-time case studies, right? There was an outage into Geo services for a couple of days. People were facing lot many issues. They lost lot many customers because their subscription went to ATAL, and they gave 2 days of free data. So that is what is their action. So once you get the decision that okay, this is what happened, this is how my subscribers went down, and I need to gain them again, then what kind of actions should I take? That action was to offer 2 days of free internet or 2 days of free services. It was already there. So what they did, this is what action they have taken. They have given the offers. If you are having some web application, you can give offers on web. If you are online shopping, if you are, so in every industry this works the same way, because this is not a technical framework, it is completely business framework that everyone should follow in every application. So this is how they will take the decision that okay, this is the action, and you are providing some offers. And finally, we need to keep on measuring the results. After providing the offer, does Geo get the subscriber back, or the porting happen? Did the number of subscriptions increased? This is what they do after the impact. This is the data science life cycle that we should follow for any problem. the main issue in every solutions, if it fails, is the lack of understanding of the domain. So whenever we work, we first try to understand what is the domain and what is the business perspective of the domain. So for an example, if I am working in a telecom industry, I would be knowing how these call centers are working, how the calls are received, what an agents can do, what are the handovers, how virtual agent can be implemented. If I know about the telecommunication industry, then I can create virtual agents in a better way. So the first understanding should be the business understanding. What kind of problem are you going to resolve? So there is a framework from Google. Everyone must be knowing, like Google Dialogflow, which is used to create agents. Now, sometimes we also get some these kind of requirements, like we want same kind of agent which can do multiple tasks, but it's not a good idea. Same agent should not be doing same conversational agent. I am talking not the AI agent. So same conversational agent should not be handling all conversations related to different kind of domains. If you want to develop a bot, if you want to develop a virtual agent for healthcare domain, you should be only focusing on the healthcare domain. So that is what we should understand very first, like what are the business problem we are trying to resolve. Next, we need to collect the data about that only. We are going to understand whole pipeline, how we utilized and how we resolved the problems. So next, we need to collect the data that is required. So if I am talking about healthcare, now apart from a data science perspective, there are a lot many other IT, or I would say specifically computer science fundamentals are useful. So when you collect the data, if your domain is healthcare, what would happen? So according, there will be some compliances according to the countries. So you cannot collect any personally identifiable information. That is called PII. So when you collect the data, when you take data from Kaggle, it will have some PII information. It may not have some PII information, but you do not bother while working on the data. So when you work on data from Kaggle, you create the model, you get the accuracy. It is possible that you feel that the work is done. But when you work for a healthcare industry and when you utilize their data, actually you do not get a data with naming names. So it is a kind of redacted data where first name, last name, this kind of data would be replaced, and then you need to work with that data. So when you collect the data, once you understand, you collect the data. Here you need to do some more pre-processing, because you are going to utilize those data for certain modeling in future. That requires both the things, not only technical aspects but the business compliances also. So next comes data cleaning. So like as it is written, like you cannot make good soup with dirty vegetables, right? So in data cleaning you need to perform some now there are two different aspects again. When you do data cleaning for some Kaggle projects or for some personal projects, what you do, you remove null variables, you remove missing values, or maybe you input some data, you follow the same distributions of the data, and then you create a new data set out of your raw data set. But when you talk about the industry solutions, we need to follow certain protocols. And so for an example, there are certain companies which use their own file formats. So generally we use CSV format, but when you talk about the larger models like LLM models, they use their own buffers, they use their own protofiles. So here data preparation also means not only data cleaning, but it means data cleaning and transforming the data into a format which your industry is preferring. So Amazon has their own framework, Google has their own framework, Meta has their own frameworks. They all are having their own way of utilizing data in certain format to make the process faster. Because when we train a model into maybe Colab or into some Python, the model is not that much optimized for deployment. We keep on compacting the model, but when you use it for an industry application, it should be faster enough. It should be having some lower latency, I would say. And even sometimes a customer may come up with that, okay, so we have seen these kind of situations where customers say that we the latency of your model responses should not be greater than 0.8 second. So in that case, you need to keep on doing some work on data also, that okay, this is the way I'm going to present my data so that it can be processed faster. Next, EDA, you all must be knowing, like this is the same for same data analysis that everyone does. What are the data problem in that, what kind of data is there, whether there is a distribution, what kind of distribution it is, what is, if is there any data imbalance, okay, what kind of data, what are the important columns in the data, if it is not, then can I drop the data. So all this exploratory data analysis goes to in this step. And next, we train the model. Once we have the model ready with us, we need to deploy the model. Now these two are very much different from industry and academics. So when we train a model, or maybe we do not train a model, we use a pre-trained model. So there are something called so people are using containers. You all must be knowing, like Dockers and containers, right? What we do in deployment, so generally we are deploying our models into cloud run services, where we create an app, and there we are having some API that we created, and we can directly utilize that URL. We can ingress and outgress. So there is a framework called Terraform. We use the Terraform to automate whole the process, and all the code goes to GitHub. So when you talk about deployment in the industry, it doesn't involve only creating a model and putting it somewhere. Like, so generally what we do in Colab or in Python, we create a model, we export the model in some pickle file or some uh, model formats like LZ or something, and then we are utilizing them again. So this is not the way it is deployed. Here you need to create a container, you need to have your code into GitHub, because what happens after deployment, after the consumption, you keep on monitoring your model, you keep on taking the feedbacks. As I said, there may be some data drift, there may be some concept drift, which may lead to the degradation of performance. And when you have it, what you need to do, you need to adjust your data, you may need to adjust your features, you may need to adjust your deployment pipeline. So you may need to change something in the whole process. And that is why now if you change it, if you redeploy it, then it may take a lot of time. Second, it may not be a good way to maintain the pipeline. So what you need to do, let's assume you are following all these 7 steps, you will be having 7 different Python files with some Python classes in it, and you will be having a main class, and then you will be having a whole template and readme and everything into GitHub. You understood there is an issue in the model. I need to adjust the weightages only. What I need to do, I need to change here and here. So when you change this data, like cleaning and modeling, you change these 2 parts. You prepare the whole container, you change into your GitHub repo, it is automatically deployed into container, and then container to cloud service, and finally you have your app running up and running. So that is the scalable solution we should think of when we manage. Okay. This is the slide, like how you can grow as an AI or ML or data science or conversational AI engineer. So the left side is the technical foundation that you require. Right side is having academic relevance. So this is where research is going on, like responsible AI ethics, explainable AI. So I'm going to share some code for explainable AI using Lime, and we are going to try it also. Data you cannot directly use. I'm going to share some scripts, collab, and also the material for the data. So then edge computing and TinyML, here they are working on IoT industry version 4.0 research, and how you can use AI tools for research. So these are specifically for academic relevance. So let's understand. So cloud computing, why it is there for data science? Because now with the, like we have a huge amount of data that cannot be directly processed into a normal computing source, computing assets, I would say, or resources. So that is why we need cloud computing. Also, as I said, like when we deploy the model, it is good to have it on cloud, right? Or maybe if you have some issues like your company compliances doesn't allow you to have your data outside of certain region. So when you deploy a model for a particular industry, so for an example, again healthcare, so if you are working with Reliance, then it may be possible that Reliance will say that my data should not be going outside of India. In that case, you need to select some region. So that kind of regionalization can be achieved through cloud computing, that okay, my data is on cloud, but it is within Mumbai only. So this is how it works. What you need to do, so you need to understand these cloud computing concepts, because nowadays if you want to work with as a data science engineer, you must be knowing at least one cloud service. So whether whatever it may be, it may be AWS, it may be GCP, it may be Azure, but you must be knowing one cloud computing frameworks like GCP or service provider services. So like if you go about talk about GCP, it is Vertex AI. If you talk about AWS, it should be SageMaker. So this is the way you need to understand at least one cloud computing resource. Next, you need to know about the some open source tools like Python, the libraries in the Python, then Docker, then GitHub. So these kind of tools you should be knowing how you can utilize them into overall development of the data science pipeline. Next, you should be knowing about the advanced algorithms. So initially, so if you see within 1 year, there are a lot many algorithms. So if I see a couple of years back when I was working on Smart Reply, there was only LSTM and BART model. Okay, there are two, BERT and BART. So we were using BART model. Okay, so there were only two algorithms that we were utilizing, and within 2 years, if you see now they are having Gemini 2.5 plus and OpenAI, and then GPT-5 is already launched, right? So day by day, new sophisticated algorithms are coming up. You must be knowing how these algorithms are working, not mathematically maybe, but at least you should be knowing that which algorithm can be applied on which kind of problems. Each and every algorithm cannot solve every problem. Okay, so you need to select an algorithm to resolve some issues, and then you need to work on that algorithm. So you should be knowing at least all the advanced algorithms, that how they work, what are the main, I would say, gist of the algorithm. And you should be knowing managed services. Nowadays nobody is going to train a model. We should be knowing the model concepts. So still we are learning like how ML works, then what is the supervised and supervised learning and all that. But now we are not going to train the model. Why? Because there are a lot many managed services are there. So like if you talk about Google, so they are having this model garden. You pick up any model, any free model that we have, like DeepSeek, the latest one, you can utilize from there, or maybe you can ask Gemini. So you should be knowing how you can utilize pre-built solutions and what can be the configuration to resolve your problem. If you know this, it may be possible that you do not know complete algorithm over here. So this way you can develop a solution. You should be knowing cloud computing resources, how you can utilize. You should be knowing how you can modify the code. This is more useful for modifying the code. Open source tools are more useful for modifying the code. Codes are already available. You may get some code. So uh, I come across lot many times to these questions by different people, that is it possible that AI will replace the human developers? I would say no, because there would be requirement of the people who can monitor the code also. So if I ask Gemini that okay, you need to develop this code for me, the code will be developed. But then what is the authenticity of that code? Whether it is a genuinely working code or not. Let's say the code is given by the open source, it works fine, it gives you the expected result. Sometimes it is not okay to accept. And that is why the field is raised that is known as the responsible AI and ethics. It may be possible that your model is giving good result, but it is not ethically correct according to the industry standard. it is not having some transparency. It's a kind of black box, right? So all the deep learning LLM models, they are having black box. They do some hallucination, they have some bias. So we are going to see this, like how it works. So that is where you need to understand, like how you can make your model responsible, how you can explain the outcome of your model. These two fields are kind of in research areas right now. And next is IoT version 4.0. These are for academics. Like you can integrate your research with these services, and you may get some very good solution of a problem. Okay, now we are going to understand couple of case studies. So let's see this video. I'll just explain what they are doing later.
Let's do this. Either you're going to do AI or AI is going to happen to you. We're leaning in and we're learning our way through it. I'm Ashley Daniels. I am the Vice President of Product Management for Omnichannel and People Technology for Best Buy. Our stores are still incredibly important. And at the same time, digital has never been more important either. And customers tell us they are looking to bring the two together. We right now are doing a lot with CCAI, contact center AI. It's at the core of our business. So if you think back in the day, the contact center agent is taking notes and trying to figure out how to summarize while they're talking to you. Now we're actually auto summarizing. And what that's doing is it's reducing the average contact by anywhere from 30 to 90 seconds. So you can imagine how impactful that is for the customer, but also the cognitive load for the agent. Our employees actually can spend their time on empathy and understanding and really connecting with the customer and wrapping their head around the customer's need. And now within the auto summarization capabilities, you can actually create structured data. We're able to get our heads around what is actually driving contacts and what would we need to change upstream, which is incredibly powerful. One of the worlds where we've always needed, people who have 20 plus years of experience to do the work is around in-home repair. What we actually did leveraging AI is we built a parts prediction capability that tells you the exact percentage certainty that we have the part that the customer actually needs. And so we built that kind of foundational capability. And then we're actually weaving it into the contact center agent's experience. And it'll get further embedded as we get deeper down with CCAI. And we're able to potentially serve it up in the chatbot. Like, hey, we see you need a part. We're going to automatically order it behind the scenes. And so now we've allowed our most experienced folks to deal with our most complex challenges, which really gives them a lot of energy as well. So it allows us to position our talent a little differently.
Okay, so I hope like you understood, like they want to resolve the problem. Best Buy is one of the largest shopping, or I would say e-commerce channel in various countries, like mainly in Canada. So I want you to also answer some questions. So let's discuss this. Like, this is the use case. You need to modernize your contact center. So believe like you are someone from the Best Buy and you want to resolve this. The pipeline that we have seen, what kind of uh, I would I would explain you what is the raw data. Raw data is just transcripts. So when someone calls to the call center, so these audio recordings are there, and another one is the chat recording, someone chatting, or someone is doing this message, using this message service with the chatbot. These two are the data. What kind of problems can be there and what can be the solution? Like anyone, if you can just name, like what kind of problems do you see? Or maybe you can think of some e-commerce service in India, like GeoMart, or maybe a Flipkart, Amazon service. Anyone, like, okay, one of the problem, as he explained, that uh, when someone is talking to the agent, they need to summarize the whole call while talking to the agent. So that can be one of the problem. Like, okay, I need summary of the call at the end. So this is one of the is one of the problem. What can be other? Let's see. What this is the business data to decision framework that we are going to use. First, what kind of raw material we will have. So we'll have the customer calls for resolutions. We will have audio recordings, the resolutions, their chat, and maybe there can be some events. So like initially they were talking to the voice bot or to the chat bot, and then they're transferred to actual agent. So this can be the raw material. Now, out of this raw material, what should be the asking? So they want to reduce these efforts. They want to improve their agent performance. They want to reduce the efforts from the customer, that they should not be keep calling, right? We face this kind of problem when we call also into some call center, like okay, you need to put one, and then you need to place two, and then you are transferred to the agent and all that. If we want to resolve this, how many calls daily they receive? This is the first question that we also ask, that how many queries you have, how many agents you have. It may be possible that they do not have enough amount of agents, or maybe we want to know like how many agents are going to utilize the service for the scalability. This is not just a kind of data science, but it is an overall solution. So we need to know what kind of resources they are going to utilize. Now, how many queries? What query is actually called for which kind of topics? So for an example, if I'm talking about Flipkart maybe, and we are mostly people are calling for order. If it is a kind of shipping service like track on Blue Dart, people are calling to track the order, whether it is received or whether it is like whatever we have asked to deliver, whether it is delivered or not. So this kind of questions would be asked. Then what can be next solutions? If we want to reduce the number of calls daily, or if we want to handle number of calls, more number of calls daily. So like X number of agents can handle Y number of calls, but we want to have Y plus X, or maybe Y plus N. We want to increase the number of calls resolved daily. What should be done? So as he said, like the writing summary time was reduced from by 90 seconds, right? So that means if you provide some AI solutions which can handle these responses, which can acknowledge you that okay, this is what you should do. So let's assume if I'm calling a college, right, uh, for admission purpose, and I'm asking that okay, this is what I need. It may be possible the person who is receiving a call may not be aware about the AI or data science course much, because whoever is receiving your call may not be having knowledge for each and every branch of engineering. So now when I call to that person, if he receives and he or if she receives and he or she says that okay, which branch are you talking about, and I am saying that okay, I need to know about AI. What happens generally, that if they do not know much about it, they may ask you to talk to someone else, or they need to search into their data, that okay, if someone talks, someone asks me about this branch, someone asks me about this kind of topics, what should be answered, what should, these two things waste a lot of time of both agent and customer, or maybe a student and whoever is picking up the call. Okay, how can you reduce this time? So one solution can be you provide every knowledge, every subject knowledge to the person who is receiving the call. It may not be possible. What can you do? Can you record the call? Can you transcribe the call, create textual data out of this, so like speech to text, and then based on this context, you create a data store somewhere. Okay, you created a data store. You have all those course materials, whatever you are having in your in your courses, everything is there. Your whole context is given as an input to the model, to the LLM model, which will fire this prompt query to the data source, and it will say okay, so as soon as if I am talking like okay, I want to get admitted to the AI course, it will take whole conversation, create a prompt, send it to the data store. Data store will find out okay, this is the PDF with AI details, and this is the page number 4. It will be directly prompted to the agent, right? And then whoever is picking up the call will say, okay, AI, we are having these many courses. Or maybe let's convert it to some other use case. You want to build a digital library for solutions, not for problem, not for books, but a kind of solution to the problems, where a student calls to the professor that, okay, I want whatever you taught in today's class, I am having some issues with this. What you do, you are having your own web application, or maybe your own web services hosted into some cloud, where they just need to write down like, okay, I want to get more details about this data or about these concepts. What would happen? There would be some PDF books into the data store. It will reach out to your API. Your API will create a prompt of this chat, and prompt both will send to the data store. It will find out, okay, I am having 5 PDF of this material of these subjects. Out of these 5 PDF, these 3 are the best, where we are using RAG, augmentation generation, right? So where we augment certain data, we get these 3 articles, we provide it to the student, and that's it. It is resolved. So these agent responses we need to reduce, we need to modify. It may be possible that sometimes whoever is talking to the other person is not responding properly. If you want to formalize this, you should have some guided responses, like, okay, if you want to do this, you should be responding this way. And so these are the solutions that you need to put in into action. Now how can we do that? As I said, like, we can create the data store, we can create a model, so, and then we can deploy it. And we kept on doing this, like, okay, how many students called the professor, how many people called for admission, and what was the resolution time, whether it is decreased or not. And this way we kept on doing this. Now this was a kind of business framework. What should be done when we talk about the life cycle of data science? We collect the data, understood that we want to improve the performance, we collect transcripts and chats from the customers, we clean them. So it may be possible. Now what can be actually problem in these transcripts? So sometimes it may be possible that customer calls and he keeps on like saying that, hello, I want to connect to the agent, this and that. There is no agent messages. If there is no agent messages, that kind of data is not useful for anything at all, right? It may be possible that customer is calling, agent keeps on speaking, there is nothing from the customer side due to some telephony issues. This kind of data is also not useful. If someone says that, okay, hello, I'm calling from so and so, I want to talk to this guy, this agent picks up the call. There was no problem, there was some information, but it is also not useful because it was publicly available. Should we include them or not? Then we will understand, okay, this kind of information, calls for receiving this kind of informations are actually very rare, like not even 1% of out of the all the transcripts. It may be possible that we do not need to use it. So that kind of data we can remove. What kind of queries we should keep, what kind of queries we should remove. Next, as I discuss the problem, I want to identify the topic. How many people are calling for which kind of. So if I'm like running a geo call center, I would be knowing, like, okay, they are calling for network issue, they are calling from recharge issue, they are calling for roaming issue. So there can be different kind of issue. I want to identify all those topics automatically from the transcripts, so that I can focus that, okay, most of the time people are calling for networking issue in geo call center. What should be done? Or maybe in XYZ regions, in X region they are for roaming issue always, or in Y region they are for some connectivity issues always. So what should be done, or how agents are resolving? Next, it may be possible that you are having a hierarchy of people. So like, if a, if someone is calling for AIML, he should be going to first to this. If he is not available, he should be going to this. Why? Because a person is very good at resolving. If A is not available, he should be going to B. Or maybe you want to have some chronology that, okay, let's first B resolve the issue. If he or she cannot do it, it will be transferred to A. So that also can be done, that, okay, if it is for X topic, go to ABC. If it is for Y topic, go to DEF, and also in chronology. Then you can create a model to provide suggestion. As I said, like you can create your own data store and then you can provide the suggestion. Next, you want to generate the summary because you do not want your agent to be busy in while writing the transcription and the summary and everything on the call. So you can create a model which will collect all audio, keep on monitoring the audio until the call is ended. As soon as it ends, takes everything out of audio, convert it into text, generate the summary and everything. Finally, you need to deploy the model. You need to create an API and keep on utilizing into some application. Now, as I said, managed services. So here in deployment, you use managed services. It may be possible that you want to go for hybrid approach. You want to utilize managed services, but you want to have it into particular premises for some services. So these kind of things can be there into deployment also. And next, you measure the performance metrics. So for each and every algorithm, as there are metrics, precision, recall, this, that, same way for each and every business solution, there are some metrics. So if I talk about this problem that we are talking, call center modernization, what we measure customer satisfaction rate. We measure whether the summaries that we generated, what is the quality of the summary, whether they are good or bad. This kind of metrics we keep on collecting so that we would understand that when we should retrain the model, when we should update the model with certain parameters, and how we should be going ahead. uh, I'll take a stop here. Any questions? Okay, I'll take that as no. So that was call center modernization. Another problem that I worked upon is a predictive maintenance one. So let's say you are having some machineries, okay, and you want to identify whether that can have some issues or not. How? So how you should be thinking about that problem. So first you will be understanding what kind of data you receive. If I want to understand the problem in a machinery, what should be received? So first we need to understand about the problem. There can be imbalance, the machinery is not having some balances, or the machinery is may have some gear problem, it may have some sound issue. So like as we have in normal machines, right, small machineries, that it is generating some echoing or something. Same way large machine would have some problem. What can be done? So how we can collect the data? So if we are talking about audio data, we can place an audio sensor. If we are talking about the imbalance, so if it is vibrating, the vibrations can teach us a lot many things. So we place a vibration sensor and we collect the data. Now vibration can give you data into three axes: X, Y, and Z. Now this data is in, so generally all the vibrations are a kind of analog, and when we convert into digital data, when we collect digital data, it is in float value. So when it is in float, it is a kind of 32-bit data, and in single packet it sends 16 packets. So you can understand like 16 into 32-bit, this is what one axis give. So while collecting the data in the pre-processing stage, what can be done? Because this data can needs to be sent to the cloud, or maybe to your application, or maybe some small Raspberry Pi or BeagleBone or Arduino, whatever board you use. You want to collect data from here to your board. You need to use certain algorithms. Maybe you can send it to cable, RS-232 or 485. Maybe you are using Modbus, or you are creating some networking using TCP/IP or Wi-Fi and Bluetooth. So these are the transfer standards that you can utilize. Now, when you give this data, first it will go to the data ingestion, right? You cannot send every data into the same package. That is because of this industry, like IIoT problem. So you cannot send these packages from a sensor will not have that capability to send all 16 into 32 bits data in the same pipe, same format, I would say same package. What can be done? So that is the first problem. How we can collect the data. Data is collected, but how it can be collected to the cloud. What we did, we broke into 16 different packages and we sent it over this using Modbus. So initially we tried with wired, then we used MQTT. In MQTT, there was this was the problem. If it is a wired connection, we received, but when we go to wireless in MQTT, we didn't receive 16 packages at a time. So we need to keep on receiving with some offset values, like this is package 1, this is packet 2. So that was the first problem that we received. Like we want to merge this 16 bit of data, the 16 packet of data. So we did it. We labeled the data, collected, and created a Python script where we collected 16 packet. Now, as this is a sensory data and this is having so many floating values, what can be done? Next, we wanted to do some analysis on this data. We wanted to train a model. Ultimately, we wanted to understand like whether there is a problem or not, and that can be done only through some models. But to access this, to create a model, we needed to understand the data. Now whenever you are having this sensory data, you need to apply some FFT and all to extract the statistics of the data, right? Now when you apply FFT on this 16 into 32 bit of data, it is taking a lot of time. So so this is what we did. We created a single script that I collected a data. I i kept on waiting for 16 packages. As soon as I completed 16 packets, I applied FFT on that. FFT was very much mathematical intensive, so it was computing intensive process. So it was taking some time. Initially, when I tried with one sensor, two sensor, it worked. But when it grew to 10, it started lagging. So the latency was increased. This is where I needed to think like, okay, what can be done now here? As I was collecting, I was processing, and then I was sending the data to the model and to the dashboard at the same time. So I was doing this into the same Python script. So that was the kind of service we have hosted. So I was doing everything into one backend services, which was creating this latency. So the first solution that we came across, and we decided that collecting the data and packaging them for one axis should be done at a one time. So like if I'm receiving for X axis, I keep on waiting. As soon as 16 packets are done, I will create another service to do all the rest of the task. So like analysis, FFT, and uploading to the server. These three services will be different than the combining services. So we created two services. Now, when we created the first service, it collected. We generally, what can be the easiest solution for this situation? If I write this data into a file and another service picks up the data from that file, that can be the easiest solution. But whenever we create a service, it is good not to involve file systems. So there should be less IO interactions. So what we did, we created a pipeline using Kafka. We are writing into some flat file. As soon as there is a signal, that flat file is sent over through Kafka streaming. So we created a cluster. Then as soon as 16 packets are there, it will be merged and given to the file. It reduced, but again, after 50 sensors, the same problem occurred. Why? Because even though we utilized different service for processing, that processing was also highly computing intensive. So now next, what we needed to do, we needed to differentiate both the things. So like FFT should be different, analysis should be different, and then uploading and processing for the dashboard should be different. So now we created 4 different Kafka streams, and then uploading this data to next, to next, to next, and then these 4 sub processes, I would say, but they are kind of services. So microservices, 4 microservices are residing into a server, and then it goes to all of them, and then it is providing here. Now, so data science problem in this is up to this only, like collecting the data and generating the model. But when you go to the industry problem, it doesn't end there. You need to keep on doing the same thing until your model is complete, and even you complete the deployment. Okay, so generally data science only involves capturing the data, doing EDA, generating a model, deploying a model, and monitoring. That's it. But when you take into the complete solution, you need to do everything in this. Okay, any questions in that? We'll see this later. So this is the code for explainable AI. The data is from Cora. So Cora had a competition last year to identify whether the question is sincere question or insincere question. Now here this problem will make you understand why biases work in the model, and why explainability is very much important. Okay, so let me open the data set. Is it visible? Okay, so this is the initial question classification data set. You can download it at later. Okay, it does have these embeddings also. So I'm not utilizing it at present. I'm just utilizing this test and train CSV. You can download and upload to the Colab. I'm going to share this. So Colab is already shared into the uh, presentation that I'm going to share. You need to utilize Lime. This is a framework to explain you what are the weightages and why it was classified was class 1 or class 2. So you need to install this. You need to import text explainer. So Lime text explainer explains you about this. So let's go ahead with this. I have my data into here, train and test data. I just read the data. These kind of questions are there. How did cubic nationalists see this province? Do you have an adopted dog and all that? So these are the data. They are the target values 0 and 1, sensitive and sincere and insincere. Okay. So next we go for this check the null values. I have already removed it, so you won't get any. Okay. Next we need to break down the data into train and validation. So that is what I did. We need to have some sample validation data. So this is just to check the question. So these are the same process that we do. We select the question, check the questions, found the validation index and all the data. Here we are creating vectors, TF, IDF vectors, because it's a textual data. Generally, this is for the NLP. So we create these two TF and IDF kind of features you can consider. Okay, and then I'm applying a logistic regression, nothing much. So this is not about the modeling. The main issue here is we want to understand how this explainability can help us. So we do this accuracy and everything. Now accuracy you can see 95%, right? So according to this model is really good. It corrected this many 80972 like very well. So that's why 1866, right? True positive and true negative. So they are very good. The accuracy is very good. Precision, recall. You see all the values are good. So according to this model is actually good. But if you want to explain someone how it is good or not, you need to check the explainability of the model. So that is what we do. We are just using target as a 1, so class 1, right? All the values, and these are the indices of that class. Now let's pick any one. Let's say 181. What we are doing, class names, sincere, insincere. We are using this pipeline. Okay, we are using Lime text explainer for the class. Now what it says, that probability, is there any place that I can buy 13-year, oh sorry, it may be some offensive words also. Okay, why are conservatives in the US against AR-15 ban but are for Gatling guns and rocket launcher legitimations? Now, actually, this is not a sincere statement, but the class is identifying it as a sincere one. So why it is classified as sincere? That is what we want to understand. So what we can do, we can use the explainer to get the weightages of each and every word. Now, guns, they are adding for this. AR, they are adding for this. So let's just check the. So what is adding to the insincere? Conservatives, guns, AR, launcher. Launcher should not be uh, this the sincere one. Legitimization, rocket should not be sincere one, right? Let's check another example. So let's check the actual one. So out, not from this, so let's say 50, index 50. Is schizophrenia a rare disease? There is nothing wrong in this, right? So it is sincere, so probability is 97. Insincere probability is 0.02, it's like 2.9% only, right? Now is, so -5, so no issues. A is no issues. When you check, you can see these all words are not contributing at all. The only word that is contributing is disease and rare. These two are contributing a lot. And for sincere, schizophrenia is contributing a lot. Now, sincere is 0.97. If you ask this to some people, it may be possible that it is not sincere. So if you want to do that, according to your use case, what you can do, you can remove those kind of words. So like I experimented with other examples where American, Trump, these words are giving some positive, some like insincere weightages, though they are not useful at all for a statement. Let me check from this, maybe 350. Why do Americans blame Hitler for his eugenics efforts when he got the idea from American government? Now, if we check Americans, right, the American words should not be considered as a sincere or insincere at all, right? So it is not sincere. If I remove that word, right? Initially, original prediction was 67%. Now it is reduced by 17%. Why? Because I reduced Americans. Correct. So this is how you can check the explainability. This code would work for any problem, not only for this one. Okay. This will work for any problem. You do not need to change anything apart from the data that you have. So like you just play around this Lime framework. What it does, it gives you the weightages of each and every word. This is specifically for NLP, or I would say textual data. You just get your data, you read your train and test data. Data is available over here. You need to, if you cannot register, you just go and click on late submission. If you cannot download it, okay, they may allow you. And even if it is not possible, I'll upload it to the drive so that you can access. But otherwise, if you try to click over here, click on download and go, if they do not allow you, just go to late submission. Okay. You just download this train, test, and sample submissions. Do not need sample, you just need train and test for playing around this code. Okay, you just create a folder over here for data. If you do not want, just remove it from here, but just make sure that you remove data for both train and test from all the codes. Read your data, check your null values. So utilize this. This is a kind of template that you can utilize for each and every kind of problem that you have for textual data, and then you can play around. Okay, any questions in that? Let's make it some interactive. If you have anything
Yes.
around.
Yes, yes. Any participants wants to ask any question, please raise your hand or click on the raise eye emoji. Otherwise, we can unmute them. Any question from the participants?
What about the noise in audio data from transcript and chat data? Okay, from trans from transcript in audio data from transcript and chat data. Okay,
Sir, it was a question about that you said that in the call center automation project, the data was from transcript of a call and from the
yeah,
chats. So I have similar kind of data. It is for student performance evaluation and it also has a audio data. So that's why
okay,
I'm asking.
okay. So if you plot that audio data, right? So you would be know if you plot the histogram, you would be knowing about you need to identify the noises from the data first. So you can utilize any pre-built model directly, like which will remove all those histogram of that. So which kind of noise? So basically, what noise do you have? So is it about silences? So generally in call center data, silences are not considered. So and in the transcript, so what we do, we collect uh, if like there is the latest model chirp, chirp, it is available. You can apply that model to convert audio to transcript. Okay, and then you can check about the transcripts. The reason it can have uh, noisy data is your transcription is not working properly. So that is the first reason that we always find, like, okay, you have not set up your language or something properly. So that is where you should focus first. So like it depends what kind of data, what kind of noise you have. So what kind of data you have in audio? It is a discussion between faculty and student or what?
Yes, sir. Kind of question answer.
Okay, kind of a question answers. So faculty is asking, a student is giving the answer, and you are using that audio, correct?
Yes, sir.
And then you are transcribing that audio into some textual format, like you are doing generating the transcripts, correct?
Yes, sir.
And the noise is maybe the background voice. So what is the noise exactly in this audio? Background voice or in like surrounding voice or what?
No, sir. The noise is like unrelated answers.
Oh, okay,
So how do I,
okay.
if I try to remove them, then it like removes the whole answer. But I
Uh,
want to capture only portion of the answer.
Okay, so that means if you ask someone that can you or simply can you explain artificial intelligence, and someone is keep on starting like, okay, when there was no data and this and that happened, and finally he said only this, like AI is a branch of computer science where they are understanding the data and creating model. You just want to capture the actual context out of the transcript, correct?
Yes, sir.
So you do. Okay, you do this. You utilize the same code I have said. Okay, what you can do, you can tag it as a important. So you label your data as an important or maybe unimportant or maybe noise. So good data, bad data. You create two classes for small amount of small set of data. You do not use a larger model. You just use logistic regression. Okay, like this, and then you check the explainability. You check this here, you will get, so here you will have two class, good data, bad data. You will understand which words are actually not contributing positively to your business requirement, and that is what you need to remove. That is the one thing to check the, I would say, correlation between your target values, your like your target is good data or bad data, and between the transcripts. That is the first thing. Second, I would suggest, so are are those questions are similar for all students or they are different?
No, sir. These are different questions for different students.
So for one question, so I would assume like if you're talking to 30 students, same questions may be repeated or may not be repeated, correct?
Yeah.
Okay. So you are having, let's assume 30 students and five questions per
Sir,
student.
I
So
saw
one,
this your example. I saw this. I mean, I asked the question beforehand when you were explaining that model, but I saw this code of yours, and you said that this you can apply to any data.
yeah,
So yeah.
yeah. And also like, so I'm not sure whether I should be suggesting this or not, but let me show you something. You must be knowing about this, right? AI Studio, and all the students are having this free for, correct? If you not,
Yes,
you
sir.
can
Yeah.
go and yeah, believe me, this works very nice. So you just start X. So there was one thing in the in one of the slide, if you see that use of AI tools in academics, right? This one. Okay. So here you start talking to the AI. So for an example, audio data and transcripts between professor and students about the answers. Answers may have data which, okay, I would not say answers may have data. Answers are given by students, but sometimes include additional or irrelevant. So I want to
Information.
select
Okay.
only contextual and relevant information and store them. Can we start developing this system using AI? I am okay to use pre-built models. Okay, you start doing this. It will, let's just see. It will take some time. Yes, we can absolutely start developing NLP task. See, what are the pre-processing steps you should have? What are the right AI tools you need to use? Okay, it will also give you the flow chart and diagram and everything. If you ask it like, okay, are there any research papers or not, it will also tell you like how you should do. So it's all about uh, utilizing AI models or utilizing AI tools. See, this should be your framework: data acquisitions,
Yes,
context
sir.
embeddings.
Hmm.
Okay, you find out the semantic similarity and
Semantic
extract.
similarity.
Now if you have some issue, okay, you started, okay, then you just need to, okay, or maybe I'm just expecting that your embeddings are already there with you, and you are saying that, okay, I'm having the embeddings, but the semantic similarity is not working fine. And then you need to upload your code here. Okay, you just need to upload your code. It will check your code. You just need to tell it that, okay, this is my code. Can you improve that code for finding this exact similarity? See, it will give
Yes.
you the how you can improve. And so it's all about utilizing these models. Okay, and it will, you won't believe it, if you have a small problem, I can just ask it, or maybe you can at a later stage you can just ask it. It will start coding. It is still thinking. It will start coding whole solution. This is what it did.
Hmm.
My data is in my data folder, and audio is in G drive. I can utilize cloud buckets from maybe GCP, let's say, because you are having free right now.
Create a Python code.
Uh, oh, sorry, it will do it. Yeah, it is Python code. So it is not able to save the prompt. Let me restart it. Okay, let's say just give this much. As you keep on doing it, it will have this. Yeah, set up your GCS bucket because you are having multiple data. You can set up your Google Drive, and believe me, this code will work.
Okay, sir.
Sir, I have one more question,
Yeah,
and that is regarding the explainable AI and NLP.
yeah,
Because
okay.
explainable AI is basically focusing on AI models, and which will helps to make them transparent, interpretable, and understandable to the humans. And
Correct.
same thing happens with the NLP, because NLP also enables machines to understand, interpret, and generate the human language. So, am I right? It's like explainable AI is using the NLP in the background.
No, not actually. So we talked about the NLP problem. That's why we used the NLP. So let's we'll come back to the same question. Let's see this, or maybe let me show you. Let me say, okay, I'm not sharing anything.
No, sir.
Okay, now you
Now,
can see, right?
now, yes.
I would suggest everyone to at least go once through this blog. You will be amazed like how people are actually working. So see, uh, this is one of the latest by Google in collaboration with Sphere. Sphere is a I would say theater, or like talkies with 1,60,000 feet curtain, I would say, like where they are launching this Wizard of OS. Wizard of OS was the first colored movie. Now they wanted to recreate for this. So when you have these kind of small images from that era, you want to convert it into this, right? For this much of large scale, what can be done? So first you need to go for the super resolution. Now when they started doing this, so they faced lot many issues like 16K LED screen. Now earlier it was like this only. What about outpainting, right? So when your curtain is very smaller, it may not include legs of the person, or maybe so there is some lion and tiger and all those, so not legs, and some not some sceneries. What can be done? You need to do some outpainting, right? Now, when they created this outpainting and they checked this performance, even they were amazed by the performance. Now here, if this is not accepted, actually it was accepted and it is running into sphere theaters already, but let's assume that at the end of the work, it may be possible that their work was not accepted by themselves. So maybe I create a new video. The legs that are generated automatically using outpainting is not correct. I need to have some explainability around it, that why it is not working. So when it is about audio data, explainable AI will work different way. When it is about video data, it will be different. When it is about NLP, it will be different, right? But it depends on the data. It never works. It's not like in the backend they are using NLP only.
Okay, sir.
Okay. So there is a
Okay,
video.
sir, can you? Yes, sir. Yes, please go ahead.
Yeah. So I do have a video for, so let me just, we are not going to going through the whole video, but we'll see that how they are actually identifying these problems.
Faith. What you're seeing in the Wizard of Oz is clearly a leap of faith.
You are now a member of the Legion of Courage.
We got that working, we got this working. What's our next problem? Sometimes while you're looking at a close-up of a character, the bottom half of their body is missing, their arm is missing. How do we actually complete these characters so that we can experience them as though they're standing in front of us?
Oh, whoops! There goes some of me again.
And so that was a specialized area of research that we called outpainting.
So what we are looking at right now is an outpainting task. The first one is the video that we want to work on, and this is what we want to extend. So this is an input to the model. We are asking the model to outpaint something, but the model has to know what to output. So in this example, right, what you are seeing out here is this section. This is where the model is learning from the training from the Wizard of Oz data.
So, for example, I really want to see Dorothy with her.
So it will explain, but so generally when we give the data, we say that it is learning from the previous data. This is the very good example of it. This scene may not have legs and the other clothes or other materials in the same scene, in the same frame, but it may be possible that it was there in previous frames. Okay, so that is why it understands from that, and it can apply this outpainting to this.
Shoes on at this frame, but I don't. If I've ever seen Dorothy's shoes on one frame, using these generative AI techniques, I can now show the shoes in a future one that we could not see her feet. The AI knows about Dorothy's shoes because we fine-tuned it on the Wizard of Oz movie.
We've achieved outpainting results that are just magic. The details of their costumes and their hair.
We've been surprised ourselves along the way for what our models have been able to achieve. And this was one of those moments we're like, wow, that's possible too.
This is really pushing.
Okay, let's get back to the presentation. Okay, so these two are the use cases, the two that I worked upon. I utilized different models also, and I worked on different use cases, but these were the two use cases which are being used in most of the industries right now. So this predictive maintenance, it is already being used in widely known industries in India, and this call center modernization. But the gist is like every problem goes in the same way. Okay, and so like what you can do, you can start with a simple problem and utilize AI tools to resolve any problem. You and never directly jump to the solution. That is the problem that students always create issues around. Like as soon as you give them some project or as soon as you discuss some actual problem to derive a solution. Yeah, sorry.
Sir, one more question. Like, for example, I would like to predict the financial distress companies. I mean, the companies who is going to be bankrupt in a future. So now this is a problem, and right now we are finding the solution using the ML algorithms. So how can we use explainable AI to these kind of the problems? Or what will be the applicability of the explainable AI to this problem statement?
Okay. So basically, you want to do financial forecasting, right? That is what I
Yes,
would
sir. Yes.
like. Sorry.
Yes,
Uh,
sir. Please go ahead.
I also need to think around it, like because the way I see explainable AI is mainly if I am developing something, whether it is actually legit enough to accept or not. That is what I like. I think of explainable AI around. So let's assume you use any forecasting algorithm, right? And it says that okay, this is the stock, or maybe this is the company that is going to be bankrupt according to the uh, financial data set that you provide. Actually it will be done or not, that can be validated by explainable AI. So I see XAI to be a validator, not to be a decision maker here.
Okay, okay, sir. Thank you. Thank you. Anybody wants to ask any question?
Okay, so
Amrin Khan, sir, do you want to say something? Okay, sir. So, Minal madam, can we conclude today's session?
Yes, ma'am.
yeah, I'll be sharing the data and everything. So it is already there onto the paper. Let me just share that once.
So thank you so much, sir, for such an amazing and informative session on data science in real world problems. So you gave us the case studies of real examples and explanations for our participants for deeper understanding of how data science is transforming industry problems and solving industry problems right now. So thank you so much for the session, sir. And on behalf of GEC Modasa, we extend our heartfelt gratitude for taking your time for this session, sir. And once again, thank you, sir.
Yeah, thank you for such an amazing opportunity. I really, you can drop me any query or information like or any details that you require on LinkedIn mainly. So I'm available. You can search for Parth Parekh, you will get it, and my email address is also with is there with Pinal madam, so you can take it. Thank you.
Thank you. Thank you so much, sir, for sparing a valuable time with us. It's really a great opportunity, or we can say it's great for us that the person from the Google is joining us today. So thank you. Thank you so much, sir.
Thank you.
Now, participants, let's take a break of 10 minutes. Then we'll have the third session at 5 o'clock. So let's have a break.